Well, welcome. Good to see you. I'm going to talk about Collabora Online performance. And Collabora Online is awesome because it builds on LibreOffice core technology there. So a whole load of good stuff in the core. And I'm going to talk a bit about that. And well, let's get on with the talk. Here we are. So to understand how we've improved performance, it's really important that you understand how Collabora Online actually works. So in the browser, we have a whole load of JavaScript, but it's very thin. It's not doing document calculation, formula engines, Visual Basic interpretation, any of this sort of thing. Your files stay on the server, but we do provide these overlays there. So whilst much of the core is rendering tiles, little squares of pixels, and sending them to the client, we want to make sure this is fluid and snappy and responsive. So it would be a madness to have a cursor blinking, require new pixels being sent. So all of those cursors, selections are done as overlays on the client. When you pan and zoom and so on, resize shapes, this is done with an overlay. So that's all happening in the client side nice and snappily. On the server side, we have the web services daemon, which kind of multiplexes all the requests and ultimately is not very interesting. It has some caches in it of tiles and so on, but it coordinates messages. And then essentially the browser is talking almost directly to the kit at the back end, which kind of isolates and contains that LibreOffice kit or LibreOffice Technology core. And this then renders the tiles and it streams them as PNG to the client. And it has this view of the whole document. So it's a relatively unusual way of using LibreOffice because it's kind of massively zoomed out. So you see the whole thing. So anything that changes, you can get invalidations for. And the kit really has then multiple views of that one per user. Those aren't backed by anything. There's no pixels behind those. And we just render those as needed. And of course, then we have the user looking at it, which has a number of cognitive biases. So we can perhaps make things faster without making them even faster, or even making them slower. We can make them look faster. So there's a whole lot of technology in the core, which is kind of cool. And one of the feedbacks we were getting was really around customer testing. We tested it with 8 people, doing random typing in our IT department. And indeed, this was a use case that actually sucked. It turns out that one of the problems was just rendering these misspelling lines. So if you mash the keyboard, you can see, I've typed some earlier here below. You produce just a nonsense. And the spell checking rendering of these lines, it was the most beautiful squiggly line in the world, but at least 9/10 of the rendering time. So that's been fixed recently, but quite apart from the silliness there, 10 times faster in this use case, is the fact that actually if you mash the keyboard, you can type 10 times faster than the average typist. So it's really, well, it's not quite 80 people that you're simulating, but it's too many. So not a terribly realistic test, but we like to not suck even for unrealistic tests. Another thing that we're doing a lot more of is generating JSON. So we use JSON to do all sorts of good things around the user interface. So we really want to be building the user interface on the client side, so we can do all sorts of good stuff with CSS and theming and make it look attractive. But the problem is that lots of events generate these JSON, and previously we were doing this amazingly expensive JSON work that would just duplicate trees left and right and left and right. So thankfully Noel wrote a new JSON writer, ultimately creating JSON as just like a printf. So let's stream it as fast as we can out, and that has really, really helped. Similarly, image scaling and rendering. If we could, we would love to rescale the image as we're painting it. This is actually from a mobile view here, where we run a LibreOffice kit and the WSD and the JavaScript all on the same device, but of course in different threads. And just loads and loads of time spent scaling and rescaling bitmaps, just absolutely foolish. And we had a cache, of course, to stop this, but it turns out that there were multiple sizes being used, and randomly it was not working. But now we have this nice multi-resolution scaled image cache, and that's pretty cool, and it's massively faster, particularly when you zoom out a long way and you're turning very large pixels into very small pictures. That's one of the pathological scaling problems. And in online, we scale that cache, the size of the cache, by the number of the views now, so it's really excellent for lots of users. Lubosh has also tackled this horrible region compression. So there's an optimization here that notionally, saves time and space by compressing these rectangles of validation together, so you can produce one nice thing. But this turned out to be, at least cubic in the number of region rectangles, and since there's quite a lot of them, this could just blow performance right out of the water. And so this should improve all large writer documents with complex invalidations, even in the PC version. GetPrintArea. So every time we would switch views between clients, or between users for a multi-user document, we were recalculating the print area. And partly that's because that depends on your zoom level. And we wanted to get this right. And so the row heights, a bit of a problem. But it turned out that calculating all of these row heights was really, really expensive and done really foolishly. So we have span trees for hidden heights and also for different sizes. So we try and store our row and column heights as well as we can. But of course we were only iterating one of these, and now we iterate them, all of the attributes that we need in spans, and so we can do it incredibly quickly. We can see row heights very, very fast, which is great. And lots of more in core. Noel has been doing wonderful things, file opening faster, caching, fonts for better text rendering, quicker scrolling, better filtering, chart rendering. I mean, everywhere you look, there's exciting opportunities to get involved. So if you're interested in performance improvement and profiling, we have lots of good things that you can come and do in LibreOffice everywhere. We also used to paint to an invisible window, 1x1 pixels, which doesn't sound expensive. But unfortunately, when you're scaling huge images to then paint them at something that doesn't exist, you're just wasting your life. So lots and lots of good things fixed in the core, and many of that shared with LibreOffice. So that's the core kit piece. Then we've got the web service daemon. Turns out that actually there's a whole load of non-obvious things here too. So for example, a standard vector of char is a nice, safe way to allocate memory, and that's really cool. But the problem is that if you're shuffling down a vector in whatever fits into your SSL stream, so 16K is the maximum chunk you can push into there, when you shuffle 20 megabytes of image data out 16K chunks at a time and you're just copying it down, well, that's 1,200 times we're shuffling a vector down of 20 meg. That's really not very fast. And so we created a new buffer class that wraps this, and we try and move it in sensible sized chunks, lots faster and quite simple, with some transient memory usage, but yeah, nothing significant. Another thing we fixed is STL on Android is unbelievably bad. It's really incredible that you see this on the profile at all, but yeah, so just deleting a vector of chars seems to be doing some kind of loop to assign them all to 0 or some monstrous folly, and the same for allocating. So it actually turns out just using standard C allocation semantics incredibly quicker. Of course, C++ on Android has always sucked. I mean, we've had to patch STL in the past to even make it work at all. But it's hard to believe this, but shifting stuff in the vector there, more expensive than scaling the bitmaps, rendering the tiles, all this sort of thing. So luckily are now gone. Quite hard to believe, but well, yeah, there you are. Merging key events. So obviously when you type a lot of key events, we would be sending lots of them individually, and this can be a bit of a silly nonsense. Much better to push it in one chunk, and then you have that unified layout and rework of the screen. So if we're falling a little bit behind, we can then catch up and get ahead of the game again. So that's thanks to Tor for doing that, and also merging backspace delete events and so on into that to make the queues shorter. What else? Asynchronous save. So one of our problems is that when we save a document, and we like to auto-save regularly, we would broadly stall because it was a synchronous operation, not just for the save, which we can do very quickly for small documents, but also for the upload to the file sync and share. And sometimes we work in very loaded systems, and it's bad if the load on the file sync and share solution is propagated to us. So now we do that asynchronously, and so we do that load and that save and upload broadly asynchronously. We don't do the core save asynchronously, but I think we've got some clever plans around that. It should be possible to fork the process and do copy on write editing as you move on and save in the background and then close that down. But we're leaving that for later. So the bulk of the work here really was around JavaScript. So it turns out that much of our problem we thought was in the connectivity, or or our scope for improvement was in the network latency or in the rendering performance, and actually it turns out all of that was almost irrelevant. The browser is really the big badness. So, and we found that through end-to-end profiling. So one of the interesting things was just correlating our logs with the browser logs and going, wait a minute, why does it take 5 seconds to get from there to there in these weird corner cases? And yes, well, we'll see why why this is useful. But we've got some nice built-in profiling now, and we push that back over the WebSocket so that you can get a single piece there. So if you triple click in Help About, all sorts of debugging becomes possible. If you've enabled this, you can click Performance Tracing, and you can build a single JSON file you can load in the Chrome tracing that will then follow. Well, you can see events being, so a keystroke going through to the web service daemon to the kit, re-render back, pushed into the client, and then shown. And so it's very easy then to help optimize those interactions. And yeah, as I say, we were mostly wrong. There are a whole load of silly things here, like just touching the DOM seems like it wouldn't be that expensive, but of course this then pushes off loads of things that could happen. So well, I'll show you. So with the WebSocket particularly was particularly annoying because one message is processed at idle each time. So in order to get the next message, you have to get to idle. And so if on each message you touch the DOM in some way, you can easily force a re-render of the whole screen for every WebSocket message, which is particularly painful if the re-render takes, tens of milliseconds. And you can then end up with a queue that grows inside the browser. So it doesn't throttle the sending of WebSocket messages at the server side. It just buffers them. So you get like 128K of queued up WebSocket messages. And yeah, that's a problem. And so actually when you typed, you would actually see a render of each tile appearing, one per frame. We spent a lot of time, and perhaps you can see that in the profile here of tiles coming in. So wouldn't it be nice if we could slurp all of those? So actually by adding a delay, we can make everything quicker because we can pull all those events in. So we're idle still, and we pull all those events off the WebSocket, slurp them in, extract the text messages, extract the images, which is also an async loading problem, which is kind of horrifying as well. So like, even though you have a base64 string, you can't synchronously load the image. It has to be done asynchronously, which is another time around the event loop. And then, bingo, you can emit them all in great big chunks. So you can go from nothing to something much more rapidly. Another foolish thing here was just the GC pressure and the time spent building base64 image URLs. So quite amazing. We used to just do this string plus equals, so this, we add an extra byte from the char code and then we convert it in a single shot to this thing. And now we have a base64 image that we can then asynchronously load. It's complicated in the first instance, but it turns out this is really foolish because it creates a whole load of substrings. And this can't be optimized, or typically JavaScript browsers don't optimize this. So you end up with just allocating a squared number of strings, each growing in length. It's ridiculous. So instead, it turns out if you pass all of these things as parameters to the from char code function, and you pass many strings, then it's very much quicker, and you generate one string. The problem is you can blow the stack. So you pick a magic number that you think the stack size is, say 4K. And then you can build a set of strings, and life is, very much quicker and very much less painful for the GC. So another thing that we do is try and avoid redoing the same work. When you see a profile like this with the same pattern again and again and again, this is particularly bad. So there's no point in updating any of these things, or particularly like tables. So you can see these table handles being destroyed and recreated loads of times. So actually we then just do them all once at the end. So we process all the messages that have come in, and then we update the DOM, and we create one set of handles, and life is good. And if it's the same table structure as last time, well, let's not quibble about that. Let's not do it. Let's just ignore it. So we now have a messages done event, which is very nice. That's fired when we've emitted all of these slurped messages and updated our internal state. Then you can queue up your refreshing till the end, and so that's kind of cool. Other silly things we found. So the jQuery nonsense. Turns out that there's this select to thing that someone has used. Everyone is cargo culting in some new NPM module from somewhere that seemed like a good idea at the time, and this turns out to be a really bad one. 800 milliseconds of startup time, just doing nothing useful, with some overly complicated jQuery selection thing for font lists. Unbelievable. And of course, we run this in our profile now under JS DOM, and it's even more expensive in JS DOM. So like 5 seconds of CPU time, you really notice it. So thanks to Mert for fixing that. And we use now native JavaScript and do just a much simpler algorithm. And hopefully we'll kick that code out shortly. I'm sure it's very useful in some other case used sparingly, let's say. Calc. So we've done a load of work on Calc to try and do client-side rendering. So header, row, and column calculation is a bit of a nightmare because it depends on the zoom level. But we now managed to push all of the sheets, row and header, column information to the client so that we've got it there, and we can then predict the size of all cells. And in theory, we could reuse that to do cursor navigation purely on the client side, modulo merge cells. And there's a special rounding nightmare that we need to do to get pixels that don't create ugly looking rows and columns. But that's now all done in the client. And that means that things that people tend to do who are spreadsheet users, which is kind of idly flick around the spreadsheet, jump to the bottom, jump back again, now work really snappily. So it's all done on the client side there. So in the future, we could do other things like, for example, rendering cells as tiles, so changing our tile size down to the cell granularity so that the spreadsheet really is a whole load of stuff that you have on the client. But we'll see. It's going pretty well for now. So in terms of ongoing work, we continue to do a whole load of things. I have a branch here for deltas, which is kind of cool. So at the moment, we refresh and re-render and recompress tiles whenever we have a change. So this thing goes to the client side, and those tiles are very similar to the previous tiles. So if I type a period, for example, this dirties the screen, re-renders a tile, and all the real changes is just a few, maybe 4 pixels, or maybe, depending how beautiful the period is, maybe more, and sends them to client. And it seems like that's kind of a bit of a waste. So it turns out that actually, if we diff our tiles for a bit more memory cost on the server, but some megabytes per view, then we can actually just send deltas there. So this gives a massive reduction in bandwidth. And for some operations, like simply hitting a new line or enter and shifting rows down, we can optimize these things and apply them on the client. And of course, when you deflate that, our deltas start off being as small as the compressed PNG result, and they end up being handfuls of bytes, 100, 200 bytes, something like that for a change, which is pretty small. We then inflate those in JavaScript, and we get this very nice 90% so bandwidth reduction. We also get a CPU saving there as well, and we're just testing this and working to get this into our next release, which should make things very much better. Similarly, canvas sections, we re-render the whole screen every time, every frame. So we blit all of these images on, and we re-render all of our tiles and our selections and all those things. And I think we can probably just dirty smaller parts of that so that we avoid repainting and touching the canvas, because they're often CPU rendered, these canvases, and it would be nice to accelerate that more. And another side effect of the delta thing then allows us potentially to avoid all of this async loading of images. When we get a whole chunk of image delta, we can actually synchronously apply this to an image ourselves in JavaScript. And it seems madness that it's actually quicker to decompress the image yourself in JavaScript and bang it on the canvas. But if you can order the things happening and make sure that they happen in the order that you want, you can control this much more. And the async loading in the browser doesn't seem to parallelize in any way that I've noticed. It takes quite a long time. It seems to require the graphics lock as well. So if you're re-rendering, you can't be decompressing an image. It just seems like a bottleneck in browsers that's single-threaded anyway. Why don't we just, have control of what's done well? Another conceptual thing to help users see this better would be to synchronize our tile deltas and our cursor movements so that we never see one slightly out of sync with another, and we're thinking about that at the moment. But hey, if you're interested in that, get involved. Other foolish things, I think, when a machine is under heavy load, one of the things that we often start to lose at is rescheduling. So if you hit a poll and you wait, you have a little timeout, then you can lose your time slice, and something else goes away. Another Chrome browser that's busily doing something in the background just consumes all of the time that you hoped to use to do something good. And so anyway, so normally we get lots of messages here that are just not really helpful. Like, there's a state changed on page headers or undo, and for some reason the LibreOffice core generates plenty of bogus state changes. Undo is enabled, we're still portrait, but and so lots of these things are sent. We now have a nice patch to reduce that and not constantly send bogus non-changes. Which be helpful, particularly when that's per keystroke. that also should speed things up, and that's going into master right now, I guess. Other things happen too quickly too. So we spent a lot of time in the LibreOffice core improving performance and getting idle handlers to execute very quickly. The net effect of that is that our word count, for example, is there. Bang! As you press the key, very shortly afterwards, the writer goes idle, and we have immediately counted the words and the characters. And of course, in the PC version, we're updating the view as well to show that, which is great and all that. But we don't really need to be updating this, per keystroke and sending an event. We can probably wait a little while, save ourselves some time, and not sweat it quite as hard as that. So that needs a little bit more work, which is quite ironic, really, because we spent a lot of time getting rid of this sort of stuff in the past and racing to idle on each keystroke. But I think we're going to need to delay some of that. We've also spent a lot of time on testing tools. It's no use being fast if you can't show that you are, and stay fast. So there's a test tool in the browser directory. If you go make perf test, this will run its own little cool WSD and then 6 people typing into it. It has a nice sample customer document there with lots of complex things in it, images and tables and weird text and headers and I don't know, all sorts of stuff, bullets and all the things that you need in your test document. And we jump those 6 people to different places. We zoom them to different levels so that there's some stress on it. And the interesting thing about perf test is we run actually the same JavaScript that's run in the browser, but we just run it under JS-DOM or JS with the JS canvas, which kind of node modules that try and emulate some of that stuff, or at least provide wrappers for that in JavaScript, which is kind of cool, albeit much slower. And then those users essentially start mashing the keyboard at top speed. And so then we can measure, and profile and see what's going on all sides there. We have another tool which is perhaps more elegant, Cool Stress, and this then connects to your local thing and allows you to load any number of documents and replay traces on any number of those documents. So it's relatively easy then to run these traces, which are typically either someone mashing the document or even typing something sensible or this sort of thing. And we approximate the response of the JavaScript client. So when tiles are invalidated in our view range, we ask for a new tile in that range, and so on and so on. And this is extremely scalable. It's easy to run 300 simulated clients at once, and then to see what's going on in terms of latency and measuring those metrics across the server. So that's extremely useful tool there. So in conclusion, well, there's a huge amount of improvement. Lots of performance work has gone into Collabora Online for the latest release, which is 21.11. A whole load of that we backported because it was so obvious that we thought it was safe in 6.4.11, had a lot, and subsequent versions. Lots of the core work is already in LibreOffice 7.2. A whole load of it is about to ship or shipping in 7.3, and there's more coming in master there. So helping all of LibreOffice desktop users as well around that LibreOffice Technology core. There's much more work to be done. Don't get the idea we've finished. There are more exciting things. There are good profiles with silly stuff on them. We'd love your help with. We're not even halfway done. We think we can make this almost indistinguishable from a rich desktop app running locally. And we'd love to have your help. So come and help us make open source rock. That's Collabora's mission. We'd love to have you help out. So I think that's the end of my talk. Thank you for listening. Any questions? Much appreciated. And I hope you've enjoyed FOSDEM, even though sadly virtual again this year. Hopefully next year we'll be able to meet in the flesh and enjoy our time together. Thanks everyone.